Welcome everyone to this series of session on large language model. And today we are in lecture 4 of large language model. And today we are trying to understand the difference between pre-training and fine-tuning. Again, this series of lecture is for three persona. One is manager or product manager. The second persona are the software developer. And the third are those who wants to pursue their career in large language model development. Now, this specific lecture is for everyone because in this lecture, we'll understand the difference between pre-training and fine-tuning. That is the first objective of this lecture. But there are other objectives of this lecture. We need to understand that is it that every model need to be fine-tuned or every model gets through the pre-training and fine-tuning? What are the models where we can fine-tune and what are the models where we cannot fine-tune? And if we cannot fine-tune, then what are the other things that we can do? And then only you will be able to understand the relevance of RAG, the relevance of prompt engineering. There are a lot of noise around prompt engineering. Why there is a lot of noise around prompt engineering, and we'll understand in this lecture. But before that, before understanding why we need RAG, why we need prompt engineering, why there is so much discussion around prompt engineering, we have to understand what is pre-training and fine-tuning. So at a very basic level, there are different stages to develop a model, to develop a large language model. The stage number one is pre-training. The stage number one is pre-training. You can say that in this stage, you're providing general education to the model. General education to the model. The school level, college level education to the model. So the model that comes out after pre-training is called as a base model or a foundational model. Okay. Now, what is fine tuning? Now, once there is a base model, you refine the model for specialization. The specialization could be in computer science, the specialization could be electrical engineer, the specialization could be MBBS, whatever be the specialization, you specialize the model. Okay. So, first, pre training, the end result of the pre training is the base model, foundational model, and it should be a generalized model. Okay. How you pre train a model? Now, we learned a model could be an encoder based model, a model could be a decoder based model, a model could be encoder plus decoder model. For the time being, because the most famous model right now in the universe is the GPT's model, so we'll take the reference of GPT-3 paper. Okay. So we are trying to understand by reading the GPT-3 paper that how they pre-trained the model. Now, for pre-training any model, what you need, the number one necessity is a large data set. What is large data set? What is number two necessity? The number two necessity, it should be a large model. What large model stands for? It should have large parameter. So let's go directly into the paper, the GPT-3 paper, and you should study this paper, which is large models are few short learners. You can Google it. Now, first of all, what we said, we need large data set and large parameters because large model stands for large parameters. Okay, we got large parameters. Can you see large parameters? GPT-3 is trained on millions and billions of parameters. Millions and billions of parameters. So large model, which means large parameters, large amount of parameters. The second is large data set. So you know that GPT-3 has been trained on large amount of data set, and you can see that they have taken tokens, 410 billion tokens from Common Crawl, 19 billion from web text 2, from books, different books, they have taken 12 billion and 55 billion, and from Wikipedia they have taken 3 billion. And if you take the weights, then they all had been trained on how many tokens? It is written here. It is trained on 300 billion tokens. So large data set. So these were the two necessity to train any model, whether it is an encoder based model or a decoder based model. Now these data set should not be labeled. Should not be labeled. First of all, most important, it should be unlabeled data. And in other term, in the language of large language model, we say it should be raw text. It should not be labeled. You do not provide any information about the text. And most importantly, it should not have any task assumption. You won't force the model to do anything. Nothing. No labeling, no task assumption, no instruction, nothing. You are not generating a specialized model. You are generating a general model. So do not label the data set. Okay. Then how the model will learn? The model will learn only based on simple objective, next token prediction. That's it. In the last session, we discussed about it. We discussed about masked training. For example, the whole sentence is Amal loves to read book. So what you will do, you will let the model predict the next word after Aman loves to. The model will predict read, the model will predict other words, and then the model will know, okay, whether they did the production correctly or incorrectly, and then it will change the weights through the self attention mechanism or through the neural network maths. They will change the weights. This is the simple objective that you provide. You don't provide anything. The model has to predict just the next right token. In our discussion, we are saying token is equal to word. However, token can change as well. That's it. That is a simple objective. Let's read the do's and don'ts of pre-training, the stage of pre-training. It should have simple objective. Simply predict the next token. You don't provide any information about task. You don't provide any information related to label. You don't provide any instruction. The model should be large. The model should be large, which means large amount of parameters, billions of parameters. The data should be large and it should be diverse, not specialized, diverse. And that's why you just saw that GPT-3 had taken data from multiple different sources, so diverse, but it should be high context data. It should not be low quality data. It should be high quality data. And the goal is generalization. The goal is generalization, not specialization. That's it. Now, in all these training, definitely there would be a lot of cost, the cost of data. You need GPUs, that's why the cost of computation. And I think the cost to train GPT-3 was around $4 million. But it gave what it gave. You gave the data during the pre-training, the model, whether it is an encoder decoder based architecture model with self-attention mechanism and weights and neural network, that model get trained with this data, which is a raw test data, but the output of this is a foundational model. The output of this is just GPT, a foundational model. Now, very important information. Is GPT-3 a fine-tuned model? The answer is no. GPT-3 is not a fine-tuned model. Is GPT-5, the base model of GPT-5, is not a fine-tuned model. The chat GPT that you're using with GPT-5 is a fine-tuned model. So every model need not to be a fine-tuned model. And when you read this paper, please, I recommend to read this paper. When you read this GPT-3 paper, what they are mentioning, even in abstract, they are mentioning, you just read the abstract. In the abstract, they are mentioning that the model do not require fine tuning because it will make the model specialized and we want to create generalized model. So actually in this paper, they have criticized fine tuning. What I'm trying to say that you should not be doing fine tuning. No, I'm not saying that. What I'm trying to say that it's not necessary that every model need to be fine tuned. So if anybody comes and say that there are two stages of model development, large language model, then all the stages are not compulsory. Fine tuning is not compulsory. Okay. Let's understand what is fine tuning. At a very high level, as we mentioned, that the fine tuning is related to specialization. It is related to specialization. Why? Why we need to specialize these good model, foundational model, because of these problems. First, example, you're working in healthcare or I'm teaching finance. Whatever I'm teaching, the details, the nuances, the nitties and gritties, the model is not aware of that. They don't know when the stock price had risen in the past and when it has fallen in the past. You have to provide those information if you're working in the finance field. If you're working in legal and compliance, then the model is not aware of the different criminal cases and civil cases. You have to provide those information. Okay. The problem with the base model, they don't follow your instruction. They don't follow your tone because your tone is very specialized. Why? Because you know your data, but the model doesn't. And that's why what model does at the end, they hallucinate. What is the meaning of hallucination? In the model space, they start doing guesswork. That's it. They start doing guesswork. So your base model, your foundational model, now this is GPT 5.2 and it is Chat GPT 5.2. It is a fine-tuned model. But can you do fine-tuning on this model directly? We'll talk about it. But it is necessary to understand if you want to avoid hallucination, guesswork in your specialized task, you need fine-tuning. How you fine-tune? Now you provide a label data and you provide specific data from your domain. Label data and specific data. And then you train the model. Now, when the model is being trained, what is actually happening? When the model is training here, what they are doing? They are assigning weights to different parameters. When you are actually doing fine tuning with these datas are actually going, these labeled data are actually going into the model and changing the weights in the model. So if I want to define in one line that what fine tuning is doing is taking a pre-trained base model, pre-trained foundational model or base model and updating its weight using a task specific labeled data and also instruction. So when you provide the data, actually the maths happening is it is going into the model and changing the weights. Now the question is, will GPT-3 or GPT-5 will allow that? No, they don't allow that. You cannot go inside the model and change the weights. So the model has to be an open model. So you have these open model where you can actually change the weights through their APIs. It's Llama, it's Falcon, Schema. You can enter into these models and change the weights for your use cases, for your specialized cases. So if you want to develop a customer support, you can enter into these model and you can change the weight by providing the label data. And it's very easy and we'll go through that code in our lecture, in upcoming lecture. It's not very complicated. It's simple. Okay. So what we have learned? We have learned that every model need not to be fine-tuned, but every model can only be developed. The base model can only be developed through pre-training. So pre-training is compulsory. The pre-training is done on unlabeled data. You don't provide any instruction. You don't provide any task level information. You just give a simple objective. That's it. And whatever the model comes, it is a foundational model. Now, if you want to refine the model, if you want to make the model specialized, you fine tune the model. Can you fine tune the model? Every model available there? The answer is no. Even you can fine tune some of the GPT-3 model, but it is GPT 3.5 and very specific model that you can fine tune. You cannot fine tune every model. The APIs are not that robust. Okay. So those closed model, whichever model, I'm not talking about GPT-3 only, those closed model, which are closed model, you cannot change the weight because it's a closed model. You have to use the open models. Okay. With that, we have understood the difference between pre-training and fine-tuning. But why there is so much noise about RAG and why there is so much noise about prompt engineering? Because if the model is not fine-tuned, if the model is not fine-tuned, then what will happen? Hallucination. So how to fix it? The only way to fix it, or one of the smartest or easiest way to fix it, it is not the only way to fix it, is providing the correct prompt, providing the smart prompt. And that's why people are talking about prompt engineering. So where you have to apply prompt engineering, where the model cannot be fine tuned directly, where you cannot change the weight inside the model. You need correct prompt. And that's why prompt engineering. If not prompt engineering, do we have anything else? Yes, you can apply RAG. So therefore, there is so much focus on prompt engineering and RAG because GPTs and some of the closed model, you cannot fine tune the model. Okay. So to remove hallucination, you have to go for prompt engineering. You have to go for RAG. Okay. So with that, we have understood overall difference between pre-training and fine-tuning and whether it is compulsory or not. I'll end the session here. So we'll meet in the next session in the series of lectures on large language model. Thank you. Have a nice day.